In this video, we're going to talk about oxidation and reduction reactions. And here's the example we're going to start with. Magnesium plus oxygen gas produces magnesium oxide. In an oxidation-reduction reaction, or simply a redox reaction, electrons are being transferred from one element to another. Now, perhaps you found or watched my video on oxidation numbers. If you have, then you know that the oxidation number of any pure element is 0. Now, in magnesium oxide, magnesium, being an alkaline earth metal, has a charge of +2. Oxygen has a charge of -2. Notice that the oxidation state of magnesium went from 0 to +2. So the oxidation state increased. Whenever the oxidation state goes up, the substance is said to be oxidized. In the case of oxygen, the oxidation number decreased from 0 to -2. Whenever the oxidation number decreases, the substance is being reduced. Now, you need to know that oxidation always occurs with a loss of electrons. Reduction is associated with a gain of electrons. Metals, they like to give away electrons. They like to form metal cations. As they give away electrons, they will acquire a positive charge. Nonmetals like oxygen, they like to acquire electrons, and so they will develop a negative charge. The substance that is oxidized is known as the reducing agent, and the substance that is reduced is known as the oxidizing agent. Metals are reducing agents because they will cause the other substance to be reduced. Nonmetals like oxygen gas, fluorine, they're oxidizing agents because they cause another substance to be oxidized, and that's the way you got to see it. So these are some terms that you want to be familiar with when dealing with redox reactions. Now let's go back to that reaction. The reaction between magnesium and oxygen gas. Now magnesium is changing into the magnesium ion. This magnesium ion has a +2 charge. And in order to become a +2 cation, it has to lose 2 electrons. Now oxygen, I'm going to write atomic oxygen because this reaction is not balanced. Individually, oxygen acquires 2 electrons and turns into oxide. Now, because magnesium lost electrons, this reaction, which is known as a half reaction, that's the oxidation part of the reaction. Anytime a substance loses electrons, it's being oxidized. This second half reaction is the reduction part, since oxygen is acquiring electrons. Whenever a substance gains electrons, or if the oxidation number decreases, it's reduction. Now for half reactions, anytime you have electrons on the right side, it's going to be an oxidation half reaction. Whenever the electrons are on the left side, it's a reduction half reaction. That's another way in which you can see it too. Consider this reaction. Zinc metal reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. Identify the substance that is oxidized and the substance that is reduced, and also identify the oxidizing agent and the reducing agent. Now, if you get a question like this on a test, to find a substance that is oxidized or reduced, always look at the reactants. It's one of these two. Don't look at the products. Now, let's find the oxidation states of everything. The oxidation state of any pure element is always 0. Now, whenever hydrogen is bonded to a nonmetal, it's going to have a +1 oxidation state, which means chlorine has to be -1. Now, in this one too, chlorine is still -1, which means zinc has to have a +2 charge. Now, the oxidation of zinc changes from 0 to +2. So zinc is being oxidized. Hydrogen changes from 1 to 0. So HCl as a substance is being reduced, even though only the hydrogen portion of that substance is being reduced. So typically, if they ask you for the substance, even though it's only the hydrogen element that's being reduced, you would say the whole substance is being reduced if you have to choose an answer on a multiple choice test. Now, the substance that is oxidized is the reducing agent. And typically, metals tend to be reducing agents. The substance that is reduced is the oxidizing agent. And this is a common question that you might see on a typical chemistry exam. Now, let's try one more example for the sake of practice. Methane reacts with oxygen gas and it produces carbon dioxide and water. So feel free to pause the video. Identify the oxidation states of every element in this reaction, and then find the substance that is oxidized, reduce, and identify the oxidizing agent and the reducing agent. So let's identify the pure elements, which is only oxygen gas. That's going to be 0. Now we said that whenever hydrogen is bonded to a nonmetal, it's going to have a +1 oxidation state. And typically, when oxygen is found in a compound, the oxidation state is -2, except when it's bonded to fluorine, or except when it's in the form of peroxide or superoxide. It's different. Whenever you hear the word oxide, the oxidation state of oxygen is -2. If you hear the word peroxide, it's -1. If you hear the word superoxide, it's -1/2. Now we got to find the oxidation state of carbon. So let's start with methane. So we have 1 carbon atom and 4 hydrogen atoms, which has to add up to 0 because methane is neutral in charge. Now each hydrogen atom has an oxidation state of 1. So therefore C plus 4 must equal 0. Therefore carbon has to have an oxidation state of -4 in methane. Now let's calculate the oxidation state of carbon in CO2. So it's C plus 2 oxygen atoms, which equals a net charge of 0. And each oxygen has a charge of -2. So in this case, carbon is going to have an oxidation state of +4. So carbon changes from -4 to +4. Therefore, the oxidation number of carbon is increasing, which means carbon is oxidized, or technically methane is oxidized. Now, hydrogen doesn't change, but oxygen changes from 0 to -2. So therefore oxygen gas, the oxidation number is decreasing, so it's being reduced, which means that methane is the reducing agent, and oxygen gas, it's being reduced, which makes it the oxidizing agent. So keep in mind, even though the element carbon is being oxidized, you would still describe the whole substance methane as being oxidized because carbon is part of methane. Now the next thing that you need to be able to do is you need to take a look at a reaction and tell if it's an oxidation reduction reaction. So consider this reaction. Aluminum metal reacts with copper chloride to produce aluminum chloride and copper metal. Is this reaction a redox reaction? So this reaction is a single replacement reaction, and if there's a transfer of electrons, then it's going to be a redox reaction. Aluminum has an oxidation state of 0, but in AlCl3 it has an oxidation state of +3. So if the oxidation number changes, then it's a redox reaction. All single replacement reactions are redox reactions. Now, if you don't want to look for the oxidation numbers, there's a quick way to tell if something is going to be a redox reaction. If you see a pure element on one side, and then that element being part of a compound on the other side, it's always going to be a redox reaction. There's a transfer of electrons. So let me give you 2 examples. And I want you to determine if it's a redox reaction or not. So both of these examples are synthesis reactions, also known as combination reactions. Sometimes a combination reaction can be a redox reaction, and sometimes it won't be. Now, if you look at the first example, there are no pure elements. All we have is compounds. When you see that, chances are it's not a redox reaction. But if you look at the second example, we have a pure element, zinc, and then that same element is in a compound. So the second example is a redox reaction. And let's prove it. So let's start with the first example. Oxygen has a -2 charge. Magnesium, in magnesium oxide, has a +2 charge. Hydrogen has a +1 charge. Now, magnesium hydroxide is composed of Mg+2 and 2 hydroxide ions. But as you can see, magnesium still has an oxidation state of +2. Now let's focus on hydroxide. Hydroxide is oxide plus hydrogen. If you want to solve it, you know that hydrogen is going to have a +1 charge. And oxygen is going to have a -2 charge. When you add up -2 and 1, you're going to get the net charge of a hydroxide ion, which is -1. So in magnesium hydroxide, oxygen is still -2 and hydrogen is +1. So notice that the oxidation state of magnesium did not change. It's still +2. The oxidation state of hydrogen is still the same. It's +1. And the oxidation state of oxygen has not changed. If the oxidation state does not change, that means there was no transfer of electrons, and so this is not a redox reaction. Now let's analyze the second example. Zinc and chlorine has an oxidation state of 0. In zinc chloride, chlorine has a -1 oxidation state, zinc has a +2 oxidation state. So notice that zinc is being oxidized. Therefore, there's a transfer of electrons, which makes this reaction a redox reaction. Now consider these two decomposition reactions. When mercury oxide is heated, it decomposes into mercury and oxygen gas. And if you were to heat calcium carbonate, it will decompose into calcium oxide plus carbon dioxide gas. So, which of these decomposition reactions is a redox reaction? Looking at the first example, we have oxygen as a pure element on the right side, and then that same element is within a compound. So the first example is a redox reaction. In the second example, there are no pure elements. All we have are just compounds. So the second example is not a redox reaction. That's a quick way to tell if it's a redox or not. So now I'm going to give you a list of reactions and determine which ones are redox and which ones are not. So feel free to pause the video if you want to. So the first example, is it a redox reaction? Combustion reactions are always redox reactions. Here we have a pure element on one side, and then that same element is inside a compound. So the first example is a redox reaction. What about the second example? Notice that there are no pure elements in this example, so this is not a redox reaction. Acid-base neutralization reactions are not redox. Anytime you have a double replacement reaction, is never going to be a redox reaction, but all single replacement reactions will be a redox reaction. The third example is a combination reaction, and there are no pure elements, so therefore this is not going to be a redox reaction. The last one is a double replacement reaction, specifically a precipitation reaction, and as we can see, all we have are just 4 compounds in this reaction. There are no pure elements, so it's not a redox reaction. So to review, all combustion reactions are redox reactions. All single replacement reactions are redox reactions. Now, synthesis and combination reactions, sometimes they're redox, sometimes they're not. And the same is true for decomposition reactions. Double replacement reactions are never redox reactions. So that includes acid-base reactions, precipitation reactions, and other types of double replacement reactions. And a quick way to tell is if you see a pure element on one side and then the same element within a compound on the other side, it's going to be a redox reaction. That's the easiest way to tell. So that's it for this video. If you want to find more chemistry videos, just check out my channel. And you can find other videos on like physics, calculus, algebra, trig, pre-cal, and other stuff like that. So thanks for watching.
This video is an introduction to oxidation-reduction reactions. We often abbreviate oxidation and reduction, so we just call these redox reactions for short. So, what is an oxidation-reduction or redox reaction? Here's a quick definition. In oxidation-reduction reactions, electrons move between atoms. Check out this diagram here. We got atom A and atom B, and there's an electron moving out of atom A into atom B. So this is definitely an oxidation-reduction reaction because there's an electron moving between the atoms. Now, we can describe the movement of this electron using the words oxidation and reduction. So let's learn specifically what both of these mean. Reduction is a gain of electrons. I know this seems kind of confusing because usually when you have a reduction of something, you have less of it. We'll talk later about why a gain of electrons is called a reduction. But anyway, reduction, gain of electrons, and then oxidation, which is a loss of electrons. So we got reduction and oxidation. What's happening to atoms A and B over here? Well, atom A is giving up one of its electrons. It's losing an electron. So at atom A, oxidation is taking place. Atom B is receiving an electron. It's gaining an electron. So at atom B, reduction is taking place. Now, we can modify these words slightly to come up with terms we use to describe what's happening to the atoms. Atom A is undergoing oxidation, so we can say that atom A is being oxidized. Atom B is undergoing reduction, so we can say that atom B is being reduced. So we got oxidation, oxidized, reduction, reduced. The big picture here is that reduction is a gain of electrons and oxidation is a loss. So I don't know about you, but when I was first learning this stuff, I found it so confusing. Why should a reduction be a gain of electrons? Usually when you're reducing something, you're getting less of it. So here's one thing that might be helpful to think about. That's that electrons have negative charge. So as you add electrons to something, its charge goes down. The more electrons you add, the lower the charge. So as you add electrons, as electrons are gained, the charge reduces. So that might be helpful to keep in mind to have this make a little bit more sense. Still, these things can be really confusing to remember. So here are a couple really great mnemonics. First is the term oil rig. This is the name of one of those big structures you use to drill for oil. OIL stands for oxidation is loss, and RIG stands for reduction is gains. This is a really good mnemonic. Here's another one you might like if you like animals. Leo the lion says grr. All right, LEO stands for loss of electrons is oxidation, and grr stands for gain of electrons is reduction. So learn one or both of these. They'll be a great way that you can always remember what reduction is and what oxidation is. Okay, oxidation and reduction happen in all sorts of chemical reactions. They're like the super important thing that makes those reactions happen, that makes them go. So to learn more about this stuff, we're going to have to look at an example of a chemical reaction where oxidation and reduction are taking place. Here's a chemical reaction that we're going to be talking about. Sodium and chlorine coming together to make sodium chloride, table salt. Now, sodium chloride is an ionic compound, which means that it's made of ions. Specifically, the sodium 1+ and the chloride 1- ions. These two ions stick together because they have opposite charges, and opposite charges attract. Now, Na and Cl, they didn't always have charges though. Over here, before they combined, they have no charge. They are two electrically neutral atoms. So in order to come together and make sodium chloride, these two atoms have to end up getting charges, and then they stick together. So let's talk about how this happens, how they end up getting charges. So we start out with Na and Cl here as electrically neutral atoms with no charge, and they're on their own. They're separate. The next thing that happens is sodium gives one of its electrons to chlorine. So this is where the charges come in. Sodium loses one of its electrons, so it becomes Na+1. And chlorine gains an electron, so it becomes Cl-1. Now we have two ions with opposite charges. What do oppositely charged things do? They stick together. So these two ions come together and they stick, making sodium chloride. Okay, so this is the process where we start from electrically neutral atoms, we have an electron transfer, we get ions that then stick together. So here's the equation that I showed you earlier that describes this process. There are a couple things that I could add to this though to make stuff a little clearer. Check out these numbers that I've written in here in the red. These are called oxidation numbers, and they give me a sense of what's happening with the electrons and with the charges. So above Na and Cl, I've written zeros. That indicates that these two atoms start out being electrically neutral. They have no charge. That's what the zero means. Then on this side of the equation, once the sodium and chloride have taken on charges, I put those charges above each element. +1 for the sodium and -1 for the chloride. These oxidation numbers help us keep track of how charges change during a reaction. Most importantly for this reaction, they remind us that sodium and chlorine start out neutral and only end up getting a charge later after this electron transfer takes place. So that is oxidation numbers, and we'll talk more about those in coming lessons. So obviously this is an oxidation reduction reaction because there is a transfer of an electron between these two atoms. I now want to describe what's happening to sodium and chlorine using these terms reduction and oxidation. So just to refresh your memory, reduction here is a gain of electrons and oxidation is a loss of electrons. So for sodium, what's happening? Is it being reduced or is it being oxidized? Well, sodium is giving up one of its electrons, it's losing an electron, so it's being oxidized. Here's a diagram of sodium giving up that electron. Now chlorine, on the other hand, is receiving an electron. It's gaining an electron, so chlorine is being reduced. So there's oxidation and reduction going on here. We can sort of show this oxidation and reduction with this picture that I drew, or we can describe it in words. The next thing that I want to do is I want to show you how we can write chemical equations that show oxidation and reduction. So let's start out here with chlorine. I want to write a chemical equation that shows the reduction of chlorine. So I'm going to start out with Cl here. This is neutral chlorine. It doesn't have any charge. It's this thing here. And then it receives an electron. So to write an equation for that, I'm going to write plus E minus. E minus is a symbol we use for electrons. So Cl, neutral chlorine, plus 1 electron gives me this guy right here, Cl1-. So this is the equation for the reduction of chlorine, for chlorine gaining this electron here. Okay, now for sodium things are a little bit trickier for the oxidation. Let me show you why. So what I really want to write is Na minus 1 electron gives Na 1 plus. But unfortunately, I can't write this because in chemical equations, we can't use minus signs. We can only use plus signs. So I can't write the oxidation like this. Instead, I'm going to write it like this. I'm going to start out with Na here, and then I'm going to put my arrow. So Na turns into Na1 plus 1 electron. Writing the electron on this side of the equation indicates that it's being spit out, that Na is losing it. It's no longer part of the atom. So to write reduction, we put the electron on this side of the equation because it's coming together with the atom. To write oxidation, we put the electron on this side of the equation because it's getting spit out. So these are the reactions for oxidation and reduction of sodium and chloride. Now I want to talk a little bit more about these two reactions and how we can combine them to make a larger, bigger picture equation. Here's our big picture reaction for sodium and chlorine coming together to make sodium chloride. Now, this reaction here really has two processes going on within it. One of these processes is the oxidation of sodium. It starts out as 0, loses an electron, and becomes sodium 1 plus. And here is the equation for just the oxidation. The other process that's going on in this reaction here is the reduction of chlorine. Chlorine starts neutral at 0, it gains an electron, and it ends up as Cl1 minus. And here is the equation for the reduction of chlorine. Now, these two equations down here are called half reactions. They show either oxidation or reduction, and they're called half reactions because they each kind of tell half the story. You put them together and you get the big picture reaction that shows both oxidation and reduction. So for every oxidation reduction reaction like this one, you can write two half reactions, one for the oxidation that takes place and one for the reduction that takes place. Now, it's super important to keep in mind that oxidation and reduction always have to happen together. They always have to happen at the same time. Because if one atom is gaining an electron, that electron had to come from somewhere. So another atom had to give up that electron. You can see that right here. The electron here that chlorine is gaining is the same electron that sodium was releasing. So oxidation and reduction always have to happen at the same time. They always have to happen in parallel. You can't have reduction without oxidation. You can't have oxidation without reduction. So that's an introduction to oxidation reduction or redox reactions. We learned that reduction is a gain of electrons and oxidation is a loss of electrons. We looked at a chemical reaction where sodium and chlorine come together to make sodium chloride. Sodium starts off as neutral. It gets oxidized by losing an electron and becomes sodium 1 plus. Chlorine starts off as neutral. It gets reduced by gaining an electron and becomes chloride 1 minus. We also learned that for every big picture oxidation reduction reaction like this, we can break it down into two half reactions, one of which shows the oxidation that's going on, and the other of which shows the reduction that's going on. Finally, we learned that oxidation and reduction always have to happen at the same time, because when one atom gains an electron and gets reduced, it had to get that electron from somewhere else, which means that another atom had to lose an electron and get oxidized.